So first of all, some English words here. We've got verify and prove. Little slight differences, but they are done very similarly. A verify question says, plug in the value to check if the left side equals the right side. And a prove question says, just prove that the left side equals the right side. If you prove something, technically you don't need to verify because proving it means that it always works. So we will do a lot more prove questions than we will do verify questions. So in fact, we'll only verify for part A. So for part A, if you were verifying, what it means is, again, you would split your side with your left side and your right side, and you would plug in the angles. So my left side and my right side, they look like this. And a verify question will often require that you need your pie plate. And again, for the chapter 7, you are going to be, I'm going to hand back your pie plates, and you are going to be able to use your pie plate on the chapter 7 test and all the chapter 7 quizzes. Well, obviously, take-home quizzes. You use them no matter what. So what does this mean? Well, you would go to your pie plate and you would find out that cos of 30 degrees is root 3 over 2. And if you know that cos of 30 degrees is root 3 over 2, then secant of 30 degrees is 2 over root 3. And this would be the start. And now we have to use our fraction rules to get a single fraction on both sides to show that they're the same. So how do I get a single fraction? I'm going to need to have a common denominator. Here I'm going to need to multiply. So we've got some options. Unfortunately, I have done lots of math, so when I look at things, I usually see the shortest option right away. So I'll show you the shortest option. In this one, I like, oh, what would happen if I distribute and multiply this out to get rid of the brackets? Well, 2 root 3 times the 1 would be 2 root 3. And 2 root 3 times the root 3 on 2, well, you see that would, I'm going to write it out. That's what it would look like prior to actually multiplying. You see a lot of things simplify. The root 3s would simplify to be 1s, and the 2 over 2 would simplify to be 1s. And so with all of that simplifying, this side becomes 2 root 3 plus 1. That's exactly what's on the other side. So the left side equals the right side. And we verified it. Very similar to a proof, except you're dealing with numbers instead of trig functions. But a proof is more powerful. So now we're going to take the same thing and prove it. So in our proof, first of all, we rewrite the question. So we have secant theta 1 plus cos theta. Draw a line where the equal sign is. This is the setup for a proof. And if I was doing this one, strategy I would use is I would probably change the secant theta to 1 over cos theta. On both sides. And then I would look at manipulating stuff. And in a similar way as the last one, if I distribute this 1 over cos theta through 1 over cos theta times 1 would be 1 over cos theta. And 1 over cos theta times cos theta would be plus 1. And once both sides are the same, then it has been proven. So this is one of the main strategies we saw from yesterday. If you can change things to either sine theta or cos theta, that usually is a good strategy to get things the same. But it's not always the best strategy. And that's where we're going to now, for part B, we're not going to verify. For part B, we're just going to prove. And this one, I have 1 minus tan theta equals cotangent theta minus 1 So I could use the strategy of changing everything to sine and cos. That would mean changing my tan to sine over cos and all my cotangents to cos over sine. And it will work, and it would work beautifully. Okay? But it's not necessarily the fastest strategy. Can you see in this one that on the right-hand side, if I change cotangent to cos over sine, I'd have fractions inside of fractions? And that's a super important, I'm going to do it. Let's do it that way first. Because it's such an important strategy that you need to have available and able to do. So if I changed everything to sine and cos, this would be 1 minus sine theta over cos theta. And this side would be cos theta over sine theta minus 1 all over cos theta over sine theta. And in order, if you're using this strategy, now what you want to do is to simplify, and simplify means get each side to a single fraction. On the left-hand side, this one to get as a single fraction, you would have to subtract. In order to subtract fractions, you would need a common denominator. So this is technically 1 over 1. I would need to multiply the bottom by cos theta and the top by cos theta. If you want to be lazy and not write the thetas, that's perfectly fine. I will just take off a half a mark every single time. So don't be lazy. You have to write the theta with, you can't just write cos and think it's going to be okay. The way that without writing an angle with theta, the COS by itself means nothing. Okay? Decide in your name which letter you could live without in your first name, right? Would you just go by Sa? Or would you go Am? Or Sn? Maybe the A. You can maybe get away with the A, right? Annual. It sounds like something that happens every year. Taking a letter out of your name all of a sudden makes it a little bit weird, right? Some names you feel like, oh, the double D, maybe I could sacrifice 1 D, but if someone writes your name with 1 D, 2 D, 3 D, 4 D, I'd just be like, it doesn't seem right. Okay? So, we have to write the theta. When writing the theta, we now have a common denominator. So this side is a single fraction. Such an important skill. I have a single fraction on the left-hand side. On the right-hand side, I have fractions inside of fractions. And we wrote down the strategy of this before. If you have fractions inside of fractions, get a single fraction in your numerator, a single fraction in your denominator. So in my numerator, I'm going to need to multiply this one by sine theta over sine theta. I'm going to draw a main line. There's my main fraction line. Now, in my numerator, I would have a single fraction, cos theta minus sine theta over sine theta. In my denominator, I have a single fraction. And a fraction divided by a fraction, we have a rule for that. That's multiplying by the reciprocal. So I take the fraction on the bottom, I flip it and multiply, and now this would be considered one factor because it's connected by subtracting. We are multiplying, and since these factors are identical while multiplying, you're able to simplify them, and once those are simplified and become just ones, this side becomes cos theta minus sine theta over cos theta. Okay? You have to get this strategy down pat, because this is like, you can get at least 80% on every single proof if you know this strategy. Can you change things to sine and cos, and then when you have fractions inside fractions, can you simplify both sides to be just a single fraction? Then you're going to be excellent at this unit. So that's why I did want to show this first. We've proven it, so I would say left side equals right side. And we're done our proof. Okay? But that's not to say that this is the best way to prove this. There are often many ways to prove something. Another really good strategy is to say, if there's a way that I can look at this and change everything to the same trig function, usually that'll be a quicker way. And in this example, you could either choose cotangent or tangent, because I can change tangent to cotangent, and I can change cotangent to tangent. So there's probably a way that I can do this a lot quicker. So I'm going to show you that if I take tangent, and I change it to 1 over cotangent, because they're reciprocals of each other, and now I use the fraction rule, my right-hand side nicely is already a single fraction. But if I wanted a single fraction over here, I would need to multiply and get a common denominator. So top and bottom by cotangent theta here. And I would get cotangent theta minus 1 over cotangent theta and that is way faster than the last method. There are multiple different ways you can prove it. And there's never going to be like, oh, your proof was too long, I'm going to take off marks. You didn't find the fastest way, I'm going to take off marks. No. You're allowed to prove something whichever way you want. So if you noticed, oh, I just want to change things to sine and cos, here it is. I just want to change things to sine and cos and use my fraction skills to get things as a single fraction because I know that method works really well, and did this, this would be full marks, okay? But sometimes if you take the time to say, I wonder what different strategies are available, okay? And I would actually recommend this while you're proving something. If your first proof seemed a little bit long, look at it and say, is there something else I could do? Is there some other way I could be creative in my mathematics to solve this? And this one I changed to cotangent. Okay? Right? There's just being creative. Take this 1 minus tan theta. I multiply it by cotangent theta over cotangent theta. Why am I allowed to do that? Because that's multiplying by 1. So if I think of it this way, cotangent times 1 on the bottom would be cotangent. If I distribute this on the top, cotangent times 1 would be cotangent, and cotangent times tangent, since they're reciprocals, would be 1. And I just proved it a third way. So we have different options. As long as the options you use follow all the mathematical rules and you don't make up new mathematical rules for fractions or something like that, you're fine. So lots of different things are available. Numbers I'd like you to circle, 3, 5, 6, and 7. And in 7, just do the second part, which is the proving, not the first part, which is verify.